good morning, everyone. Thanks for joining the second part of this beautiful workshop. This time we are going to do a small hands-on lab. It's actually not that small, it's probably around 2 hours. Again, it's going to be recorded, the session is going to be recorded, and all attendees will receive a link to the recording at some point. I don't know exactly when, but eventually it will happen. And this time I have with me Cor Rasmussen. He's been incredibly helpful for our product group as a Quest PM for quite some time, and he's did amazing things, and he's also going to do an amazing demo today. And with me I also have Gilles Leroux in the chat and Vincent Philippe Lauzon to support us answering questions that you potentially ask. And also thank you very much, Diana, for setting this up. Okay, so again, as said, today it's about the hands-on lab, so you actually get to do something. And that actually means that we want to go through a couple of steps. Potentially it might take us up to 2 hours, but 2 hours, 2.5 hours, it totally depends. And we're going to execute a couple of steps. So the first step is actually already one of the most important one, and it's downloading the PDF, because in the PDF document there's a couple of links to blob containers, to blobs that we would like to use during our lab for ingestion purposes. So please click on that link. I also pasted it on the, or you can't click on that link, but I pasted it into the chat. It's aka.ms/adx.partner.hol for hands-on lab. Please download that PDF, and then you get all of the instructions. And if you like, you can do it at your own pace and just ask questions. The way that I would like to do this session is I go through each and every step, wait for some time, wait for questions, and then I just continue. It's not really possible to make this an interactive session at that scale, so please feel free to use the chat functionality, and then we can I pause from time to time and take a look at the questions. Okay, so there's before I start, there's a question like, in case you missed the session, yesterday's session, don't worry. You can still do this lab. It's absolutely no problem. And of course, everything will be recorded. So now I'm going to switch, and I'm going to share my browser, which I'm going to use for probably the rest of this lab. But just before I'm going to switch, the step one is create an ADX free cluster. So you're going to click on this link. I'm going to do this in a second. The prerequisite for this is, and I posted this already yesterday, is you need to have some sort of an Azure Active Directory identity. And that ID identity might be your existing identity, or just like a Microsoft identity like Outlook or Gmail or whatever works here. And here's also a link on how to create this Microsoft account. So just open the PDF, and you get the link for creating a new Microsoft account. Now let me share my browser. The way to get to the free cluster is very simple. You just go here, and then you say aka.ms, and then you say custo free. Or you follow the link in the PDF, and then you go to the free cluster. Again, let's see if the PDF link is working. So we go to aka.ms, and then we go to the adx.partner.hol, and it's going to open up this PDF. So right now we are in step one. So step two, actually, so you hopefully downloaded the PDF, and you created, and you're about to create now this new cluster. Again, please have a look at this step. It's very simple. Just click on this link and you're going to be here, or open it in a new tab, which would be even better. Then you can have both things at the same in the same browser. And if you, in case you have not yet a Microsoft account, click on this link to create a new account. Okay. So let's do this together. So I want all of you, okay? I want all of you to go to this page. And in case you're already logged in, like I am, click on Create Cluster and Database. Now, again, maybe it's the 2 words for this offering, because we did not mention that yesterday. So Kusto is the internal engine of all of our offerings around Azure Data Explorer or Kusto Free. And usually if you want to try the service, you have to go to Azure, to the portal. You need to have a subscription and a credit card. And only then you can create an Azure Data Explorer cluster or a Synapse Data Explorer cluster. Okay, so it's actually a big prerequisite in order to get started with the service. So again, you need to have a subscription and a credit card. But with this offering called Kusto Free, you don't need to have all of that. You don't need to have a credit card and you don't need to have a subscription. You just go to this website, Kusto Free, and then you can create your own cluster. This cluster, let's click on Learn More to know a little bit about the specification. You can store up to 100 GB of uncompressed data. You can have up to 10 databases per database. You can have up to 100 tables. Columns can have up to tables can have up to 200 columns, and you can also create multiple materialized views. If you compare the features, you will see that actually most of the day-by-day features that are needed in order to use the service are also present on the Kusto Free. So you have KQL, you have the SDKs, you have Azure Data Studio notebooks, you have all of the time series and ML functionality, the geospatial stuff. You can even do soft delete or materialized views. Things that are not present are features like external tables, continuous export, some workload management, purge, followers. And the reason why we did not add this is because we want you to play with KQL and learn the language and try it. Now, if you create your new cluster, you can give it an arbitrary name, like your display name. The database name is just leave it as my database, and then depending on the region that from where you're joining, you can pick Europe, Asia, or North America. So if you're dialing in from North America, please pick North America, because then we will create that free cluster from one of our hosters in North America, and the same for Asia or Europe. So for me, it's Europe. Then you can also read through the terms of use. Terms of use is essentially saying that we're not guaranteeing anything. It's a free offering. We want you to play with it. And if you're not using the cluster, then we're probably deleting it just to maintain it. Okay. So feel free to read through that, also through our privacy policy if you like. I'm going to create now this new cluster by clicking on the create button. It's going to take now probably something like 20 or 30 seconds, which is, by the way, much faster than creating a regular Azure Data Explorer cluster, because for a regular Azure Data Explorer cluster, we're actually creating multiple virtual machine scale sets. We create dedicated storage for that cluster, and then all of those virtual machines will need to be provisioned, started. There needs to be the software, the right software on those virtual machines, so it takes much longer. Like starting a regular Azure Data Explorer cluster might take anything between, I don't know, 10 minutes and plus minus a couple of minutes. But this creating this free cluster is very, very fast, because it's working on some sort of a virtualized environment. So now you're ready. So you have your free cluster. It's here. Eventually, if you like, you can also at some point upgrade to a paid cluster. But right now, clicking this also giving you a coming soon. But as the note is saying, it's going to come soon. Then what else is important? Just looking at this main section is you see your cluster details. That's a cluster URI. It's actually the URI that you use in order to connect to it with tools like Kusto Explorer, or with other tools that like to use this cluster, or with like an SDK that likes to connect to that you want to connect to Kusto. So then you use this cluster UI. For ingestion-related topics like an SDK-based ingestion, you want to use this URI. And then again, you have the cluster location, which is Europe, the policies, so terms of use, and the Microsoft privacy policies. And then you have a couple of other things which are interesting. So you can ingest data, you can query data, you can create a database. Before I continue, and I just give you some more time for creating the cluster, let's quickly click on the other items that we see here. So if you go to home, you will be able to get started with KQL, so you can explore sample data with KQL. So if you like to dive in deeper into other use cases, you just click on it, and then you can decide on some use case. I'm interested in this in IoT data, so you can click on Explore, and what this is opening for you is a new experience, also called Kusto Web Explorer. And this Kusto Web Explorer, it connects you automatically to our help cluster. So that's a cluster which you can use in order to play around with some sample data. In this case, it's IoT data. And if you like to execute it, it's very simple. Just a Shift Enter. If you like to see how to run SQL on top of Kusto, you can do this. And I think we did not mention that yesterday, but you can also run SQL on Kusto. Probably I'm going to talk about this today. Other features that we're going to touch today is also dashboards. So we have a couple of we have really nice ways of creating dashboards in ADX. Today, actually, the last step of our tutorial is about creating those dashboards. Now, let me quickly pause and have a look at questions.
Yeah, do you know which region it is? The Asia, when we say Asia for the data center?
No.
I guess it's for the free cluster. I don't know which are the real underlying regions.
I don't know as well. So it's one of our Azure regions in Asia. I don't know which one it is. But probably, guys, if you like, you can find it out.
Otherwise, questions. That's not the free cluster is not going to add any charge on your subscription.
That's absolutely correct. That's the main purpose. So it's a completely free offering. Okay. There's no credit card required for that. Not even a subscription. Really, the only thing that we need is an identity, because this is how authentication works with Azure Data Explorer. We need some AAD identity, and then it can be either directly an identity from your own Azure Active Directory or from a Microsoft account like Outlook.com or Outlook.de. This is the only reason why we need to have that identity in order to properly authenticate you on the database.
And is the free cluster available only during the session?
No, absolutely not. Use it as much as you like. Per identity, you can create one cluster. Personally, I'm using it for analyzing my home automation. So personally, I'm using it, for example, to track the data of my Homatic CCU via Node-RED, and I'm sending all of this IoT data from my house to our experience, to the free cluster, and then I create dashboards on top of that. So I'm using it myself for some private things. So it's not just for this session. Feel free to keep it. Feel free to delete it, create a new one.
And give the link to friends if they want to.
And give the links to friends, yes.
What are the regions where ADX is available? Can you comment on that, Henning, on both the free cluster and ADX in general?
Yeah, so we're talking about two different offerings. So if you're talking about the free clusters, they're available in, let's say, geographies, Asia, Europe, North America. We don't really specify in which particular Azure region this cluster is being deployed, okay? If you're talking about the service, Azure Data Explorer, the one that is paid, it's available in any Azure region. Really, the reason for that is it's a base service for a lot of other services. It's a base service for billing, for networking, even for AAD. So other services are built on top of our service. So it's probably one of the very first services whenever we build a new region. Okay. Any other question at the moment, or?
Do we need to have some background for this workshop, as I am the first time joining this kind of workshop on Azure?
Absolutely not. No. I would say growth mindset. Open mindset, learning a new language, which is optimized for log and telemetry analysis. I think that's the only prerequisite for this session. Other than that, I can't think of any. Cool. Okay, so were there any difficulties creating those clusters, or are all of the attendees good?
According to questions so far. Eh?
Okay, cool. Then let's have a look at our hands-on lab over here. So what you did just now is you created your own brand new Kusto free cluster. It's your cluster. And the only prerequisite for that was having a Microsoft identity. And obviously, most of you were able to do that. So why don't we continue to the second step? Now, the second step is already going into one very, very important part of the entire service of a database. It's actually ingesting data. So let's do that. So the step 2 is generating DDL, so the data definition language, and also ingest data using the so-called one-click ingestion method. So one-click ingestion is for something that Svea presented yesterday. She also said it's not going to be one click, it's probably 4 clicks, but I think we manage it. We're going to use a specific data set and ingest it from blob, and I will just tell you how to do that. Okay, so first again, we go to our cluster, and I said there are a couple of actions down here: ingestion, query, and create database. We already have an existing database here, which is called, in my case, my database. And I'm going to click now on the ingest button here on the actions and define the cluster that I'm interested in. In my case, it's called my free cluster. And the database is my database. If I would have now more than one here, I could specify the one that I'm interested in, and then I would like to create a new table. I'm a big fan of copy and paste, and I highly recommend you to do that as well for this session. So I'm copying the new table name that I want to create. Oops. Then I'm pasting it into the new table name. Now you see everything is fine. I can advance to the next section, which is actually the data that I would like to upload. Now there are again like multiple options here. You can upload from a blob, which we are going to use. You can also upload from a local file. So in case later on you want to play with the service and you have some JSON or CSV file or TSV parquet laying around on your desktop, you can just drag and drop it on the browser, and it will upload it, and you can use it to ingest it. But in our scenario, at least in the first one, we would like to ingest from a blob. And now it wants to have an account, key, SAS, URL to this source. Don't worry, the data that we provide is just from test systems, and there's no problem with this data set. See here, I would recommend you to right-click on it and then copy the link. Okay, right-click on the data set, copy the link, then go to this window and make sure that you use the from blob, and then you paste it in here. Now you see a spinning wheel on the schema, because what is happening right now is that the service is looking at the data set and trying to infer a schema from it. And once it's done, it will be blue so that we can advance it, advance to the next step. And now we are already in the part where we are looking at the actual data that we try to ingest, and we can make some adjustments here and there. I don't want to make too many adjustments. The only thing that I want to configure here is the data format. Obviously, it's JSON. We have multiple. We're supporting some small variations of JSON. Multi-JSON also supports like multi-line JSON, and it's something that I would recommend you to use. So click multi-JSON. Eventually, you also see here like other data formats that we are supporting. So you see raw data, Parquet, ORC, Avro, text, CSV, TSV, and a couple of different data formats. I would like you to click on multi-JSON. The nested levels, that's interesting in case if you have a JSON document with some hierarchy in it, so some objects which have again like other objects, and then you would like to explode those hierarchies and create individual columns for all of them. That's not necessary for our scenario. And what this experience is actually doing for you, it's creating the DDL, so the data definition language. You can also find it if you click here on this arrow. You click on it and you see that it will present you the create table statements for creating the tables, and it will also create the mapping. So the mapping is something that Svea already mentioned yesterday. Mapping is responsible for picking the relevant pieces in the data, the relevant fields in the data, the relevant JSON properties, and assigning it to specific columns. So for example, the column fields is from the properties and the property path of the JSON root, and then fields. Okay, in case you have a hierarchy here, it might be delimited by multiple dots so that you can access the specific properties of the JSON in deeper hierarchies. Now, if you start the ingestion, if you click on the next one, it will actually start the ingestion from this sample, from this data set. So it first creates the tables, it creates the mappings, and then it's executing the ingestion. And before I'm continuing, I would like to answer some questions, because I think there were questions on like, is SAS-based authentication something that's recommended or not? Is that correct, team?
Yeah, the last question was about SAS keys.
Yeah, so ADX supports multiple ways of ingesting data. SAS keys is one of them. We call them also like storage credentials. We have a documentation on that. I'm pretty sure that the team probably already sent it to you. But we also support authentication using a managed identity. So if you would create a real world scenario with Azure Data Explorer, you will probably either connect to an event hub, so a live connection to a streaming data source, and then you would authenticate using a managed identity. So the Gusto cluster would, or the ADX cluster would authenticate with that managed identity on the event hub. And given that the identity has enough rights, it will be able to consume data from that event hub and stream that directly into ADX. There are also other ways of ingesting data, for example, from storage. as we explained that yesterday as well. So we have the capability to listen to blob created events from event grid on a storage account and then authenticate on that storage account again with a managed identity. So nowadays, it makes a lot of sense to use managed identities for authentication and not SAS keys. But for the purpose of this demonstration, it's good enough. Other questions so far on the ingestion? Okay, then let's continue. So what you see here is that the data was ingested. There was just a single blob mentioned here and it was successful, 0 failed, and you get a preview of the data. Now, in order to go to the query experience, just click on Take 10. We'll open a new tab. Let me close all of the other ones that I already created here. To prepare. So you see you can have multiple tabs in here. I'm also making this a little bit smaller. Now you see here your new MyFree cluster. That's the infrastructure level. On this infrastructure level, you have multiple databases. On the database level, we now found the table called raw metrics. If during the course it happens that you created a new table, probably somewhere in a different tab, and you don't see it under this new database, or you don't see the new database under the cluster, just do a refresh here. And this browser window will refresh its metadata, and it will find the new table. So don't worry. You also see here the schema that was created. So we have 4 columns. We have a field, which is of type dynamic, so something like a JSON. We have a name, which is a string. Tags, again, it's a dynamic, something like a, I think it's an array in here. And we have a timestamp, which is used quite often. Now we see the beauty of KQL, you get IntelliSense. I would be totally lost without IntelliSense. So I just started typing raw metrics, and then I hit enter, and by hitting enter, it automatically goes to the next line, and then you can do many things. Like from the example, you can go for a take 10, and the best way to execute it, you can also like you have to be like anywhere in this command, and if it has multiple lines or more than 2, you just need to be anywhere in this query, and then you can click on the run button. Personally, I prefer to use the keyboard because I'm a little bit faster with the keyboard. I don't need to switch to the mouse. I just do a shift enter. Okay, and then you are actually writing KQL. Let's have a look. Yeah.
Hey, Henning, with a question. Where did you get the key? I don't see it in the PDF.
Okay, absolutely, no problem. You don't specifically search for the key. So you go to page number, I don't know, 4 out of 12, which is step 2, generate the DDL. And then there's a link to the data set you see here. And then just do a right click, copy the link. And this is what you're going to use. Okay. Now, so yeah, please feel free. I think my friends in the chat will be like happy to help you. Now let's go to the next step. Okay, we only have 2 hours and we still have some queries in front of us. Now it's actually, we want to play with the data. And I mean, you can just go free flow with your cluster, experiment with it, but we already prepared some data sets for you. So you could just click on this one with the left mouse button, just click on it and it will download it. And then you can open this file. Okay, just open it. You have it in your editor that you trust. And the way that I want to use it, I'm just going to copy the entire script, copy it, and then I go to my cluster, and I'm just going to paste it in here. Okay, so very, very simple. You click on this link on the basic KQL queries. You open the file. You have it in your editor of choice. you copy all of the statements, and then you paste it into the editor. Okay, and then we have a couple of statements, and I will just now go through the statements. So the first one is count. It's telling you that there are 60,000 rows in this data set. If you want to find out a little bit more about this data set, we can also do things like dot. So by the way, commands, we have like two different things in ADX which you can execute. One is a command and the other one is a query. The difference is command starts with dot and query without dot. And the queries are read-only operations, so you can't manipulate anything with a query. So if I want to do show, for example, and then I can have a variety of choices. I can look at the already existing queries. I can use different things, but I'm only interested in tables. And I'm interested not in a specific table, but I would like to take a look at the table details. You see here that we created one table, which name is raw metrics. It's in a database, my database. The total extents, this is the underlying data structure that we use in order to persist the data. It's just one of them. It's a very, very small data set. And the total size of the extent is 3 megabyte. So it's you can see it here. The total original size is 28 megabyte, and we ingested 61,000 rows. And you would be like, what's great to see here is that you obviously applied some compression. But again, like I'm a lazy person, and I would like to know what is my compression ratio, because we store the data in a compressed column store. So I use this statement in line number 5, like I would use any other KQL statement. And I'm going to do a project, so I'm only interested in a couple of columns. So I want to have the table name, and then I would like to have the total extent size, the total original size. The total original size is the data size that that was the size of the blob. And then I would like to compute a new one, and I call it compression ratio. The compression ratio is the total original size divided by the total extent size. And because it's a double, it will probably have a lot of digits after the comma. So I would like to apply a quick function. So I want to round it. I'll round it with 1 digit after the comma. And now again, I'm executing it with a Shift Enter. And you see here that the compression ratio is 7.5. So the compressed column store was able to compress the data by factor 7. It's also very important if you look at cost. And this means that you're only paying for the 3 megabyte that were ingested and not for the 28 megabyte that you ingested when it comes to storing the data for a long time. Let's continue. Let's have a look at the actual data sets. So raw metrics take 10. We see here a couple of rows. We decided to only show some random 10 rows. With several columns like field, name, text, and timestamp. And the next in line number 15 is something that's very important for customers that use, for example, an ODBC or a JDBC driver to connect to Kusto, because those drivers, they only understand T-SQL or SQL in general. So it's something that could be looked like a compatibility feature, backward compatibility, in case you would like to use tools that don't yet support KQL natively, like Tableau or Click, or any other tool that does not speak KQL natively, and you want to use actually a SQL interface. So every Kusto cluster, and also this cluster, those 3 clusters, they come automatically out of the box with an MSTDS endpoint. which looks kind of a SQL server to clients. So if I'm executing now this statement, I will get some. Yeah.
There is a question. .show table details is not working for some on the call. Is there something specific about that?
Absolutely not. Absolutely not. It should be working for you. Just make sure that you're somewhere here in this string and just do a shift enter, and then it should be working.
And also that the my database in your left column is selected.
Exactly. Absolutely correct. Yes. Thanks for that hint. All of the commands that we're executing, they are always in the context of a database. Okay. So if you want to do a show table details, then you need to be in a specific context of a database. So please click on the database, and then it will be working. Thanks, Core, for the hint. Okay, so we were talking about SQL and the MSTDS endpoint. And if you would like to know, because what we're doing under the hood is we take the SQL from the SQL endpoint listening on port 1433, and we translate it into KQL. We're executing the KQL on the engine and then return back the result via the MSTDS endpoint. Now explain is going to tell you the query that is executed. This is of course like random that's generated KQL, but it's doing the same thing as this one. So it's projecting the fields which are interesting, and then it's taking exactly 10. Okay, so it's 100% the same thing. Okay, now you learned actually that you can connect with a SQL client via ODBC and JDBC to an ADX cluster, to a Kusto cluster. Now let's do something with that beautiful data. And what Kusto is really doing well is accessing data in JSON, for example. So again, like the first part of the query, like 27 and 28, is just taking 10 rows out of raw data, and line number 29 is selecting data from the JSON. So if you look at tags and we just double click on them, it's a JSON with various properties, and we're only interested in what? In the tag host. So we're going to get telegraph something in here, and the SQL instance field, the new column, is from the tags.sql instance. So there is somewhere, again, in tags, there is a SQL instance. So this would be SQL Server 2. So if we execute this, extend is actually appending a column to the result set, and we get the host and the SQL instance here. And this, of course, can also work in deeper hierarchies. You can do a lot more things with the JSON. Now let's get some idea of how the data looks like. And it's the first time that we're going to use the summarize expression. So summarize, it's something like a group by from SQL on steroids. So we define a couple of aggregation functions. In this case, the first one is a count. Then the next aggregation function is the min of the timestamp, and we assign it to a new column called start date. Then we have the to date, which is the maximum of timestamp. So if I'm executing this, I'm getting, again, like 61,000 rows, the min timestamp and the max timestamp. So this is data for only a couple of minutes. Let's see how much. Extend, let's call it data equals to date minus start date. Delta is 1 hour, 7 minutes, and 10 seconds. And the date type of this delta is a time span. You can also do a get schema here, and you see data is a time span. So with time span, you can do also other interesting things, like if I want to have the delta in seconds, I can do extend delta in seconds equals delta divided by 1 second. And then I know that this 1 hour, 7 minutes, and 10 seconds actually translates to 4,030 seconds. Okay, now we know a little bit of our data. Let's use the summarize with the by statement. So obviously there are a lot of names here for those different rows, and we consider them as a metric type. And now we want to understand how many metric types are in there. So we have all of those, a couple, just I don't know, 10-ish probably. Now we want to find out, and this is now very important because the first time that we're touching some of the time series capabilities, we want to find out how many metrics have been created in 5-minute buckets. By that, we're just doing again the account aggregate, and we are not grouping by some, I don't know, some metric like we could do here, but we're grouping by timestamp, and then we do a bin by 5 minutes, and we'll get the count by minutes. And we see that in this 5-minute window, we had 6,100 rows, and obviously there was a spike somewhere here at 420 where we had like 40,000. If you want to get a better understanding on and looking at results, you can also use the render command. So render will help us to render the data in something else than a table. In this case, what will work fine is a time chart, because we have the time column and some count here. So it will render out of the box a very, very simple chart. Okay, just like very, very simple. You immediately see that there was a spike. You can also use other charting, other charts that we have plenty of them. We're going to use a couple of them later. Now let's do something that's a little bit more complex. I told you that at ADX, so I don't know if I told you, but I think yesterday we covered that in Slavik's session, that for every column that you define the schema, we are creating a secondary index. And if you would like to search for a specific SQL instance, we can do this on this raw metrics data set, but it would be much better if you would have the SQL instance persisted as a dedicated column, so that ADX can do its job and create a secondary index for it to make it searchable using a secondary index. And this is what we're going to do now. We're going to do the first step by defining the logic of what we'd like to achieve. So again, the first part is just taking 5 sample data sets here, and then we're using a function to get some data out of the fields column. So you see fields is this one where you have the value column too. So it's a classic Json. And what this one is doing, it's iterating over. So potentially there might be more than one property in this JSON. So there might be value and I don't know, humidity, CPU, whatever. There might be multiple values in this field. Okay, so might be multiple properties in this JSON, and for each and every of those properties, we would like to extract the key and the actual value. And doing this is we're going to leverage a function called mvapply. So in this scenario, it will be just a single iteration of this statement. So for this single row and for this single cell, and then within this cell, we're going to use mvexpand, which will help us to address the value of this, the key name, the name of this property, and the value of this property with the regular array index. So we are expanding the data of this key value, and then we're extending the rows with a SQL metric. This is going to be the array index 0, so it's going to be value, and the actual value is going to be index number 1 from this key value. Last but not least, we are projecting. Again, projecting is like selecting the data that is interesting for us. Is the SQL matrix, the value, metric type. We're going to use another string function, which is taking the name, which is cube underscore SQL Server underscore performance, we are going to split it by cube underscore. So there will be two elements in that array. We are only interested for the second one, which is index 1. So in this case, it will be SQL Server underscore performance. Then we are interested in the timestamp, just with an uppercase T, which is the actual timestamp here. Then we are interested in the host, and we are directly going to the JSON and getting the host. We make it explicit as a string. Same we do for the measurement type. It's also hidden in text. And last but not least, we want to have the SQL instance, which is again in text, and we want to have the all of the text. So if I'm executing this, I get the actual value, the SQL metrics, the value of the SQL metrics, metric type, and all of that. So this is a nice combination of string parsing and other things. Now, the next step that we're going to do now is we are going to implement something which is called an update policy. The idea behind that is that we want to be very, very flexible during ingestion time. So we want to have a very, very simple schema. And then on top of that data which is ingested, we would like to populate a new table with the ingested data. And there should be some sort of small transformation, which is taking the data from the raw format and transform it into the target format. So think about it, even if, think about it like a small kind of ETL directly in the database. This can also be chained like a directed acyclic graph. Let's go back to this hands-on lab. To recap, we just now went through these basic queries, and now as a next step, we want to get some meat on the bone and ingest the big amounts of data and use an update policy. Okay, so now we are here. We did the basic KQL queries. Now let's go to the next step. Again, just to recap, now we just created the DDL, so we have a schema, and we have an understanding of the data. So we were probably some kind, from the persona that we were like imitating right now, we were probably some kind of data engineer. So me as a data engineer, I received some sort of a blob from somebody, and I now want to design a schema for that blob. Okay. So I took a look at the raw data. I thought, okay, if I create this kind of transformation function, I'll be able to create a schema which is highly efficient and will be performing very, very well during query time. So this is what I did right now. I made up my mind what I want to do. Now, as the next step, I would like to create a derived table from this raw metrics table, and I would like to put some feature in place which is transforming the raw data set into the derived data set. This is now happening in the second step. Now, from my experience from previous workshops, please look at the stuff at the red line at the bottom. Please don't copy it from here. You get all sorts of mistakes in your script. Let's do the following. You click again on this to get to download the advanced KQL query script. Just click on this. You will get that. Okay. Just copy it from here. And now you go to your browser, you open a new tab, and just paste it. Okay. Then you can go back to what you did before, and you have your advanced KQL script in a second tab. And we are only interested in the first three statements. Okay. The first three statements are doing the following. So the first one is going to create a stored function to transform the raw metrics, and you will see you will see that we are using the same functionality as we did before in the basic queries. The second statement is going to create a data model for us. And the third one is making sure that all new data which is ingested into the raw metrics table will trigger an ingestion into the derived table called transformed metrics. So let's start from the first one. So the way to execute this is, again, it's a command, because it starts with a dot. It says create or alter function. We give it a name. This logic is already known to you, and we execute it. You will see now here on the left-hand side that there is a new folder called function, and here's the function called transformed metrics. And now what you could do is you can just go here, type a capital T, and you will automatically get the IntelliSense. You hit enter, and don't worry, if you don't have any parameter, you can just skip the exclamation marks. And then you can do a take 10. We will execute the logic in here and present you the result in the results pane down here. Okay, so now let's generate a schema. The way to generate a schema for very, very lazy people like me is using the set or append command. The set or append command will create a new table if it does not exist, or append to the table if it already exists. And then it needs that kind of separator to come with the query part. I usually like to have it on multiple lines. So it's going to execute the function that we created, but it's not going to ingest any data. So it's actually saying limit 0. If I'm executing this, what you see here is that this new table will pop up. Okay. Now, if you're switching again between different tabs, eventually it might be by accident that this tab is not yet up to date, and you don't see the transformed metrics here. So in case you're not sure, just click on refresh here, and you will get to see the new table. Now, this transformed metrics has exactly the schema of the output of our function. It has a SQL metrics of a string, a value, which is a real, a couple of other data types. Okay. Now, last but not least, this is the point of the configuration. So we have a lot of policies, by the way, in Azure Data Explorer, like policies on ingestion, policies on workloads, policies on partitioning, caching, retention, all of that. And this is one policy that will trigger the update of data of a derived table. So we want to alter the table called transformed metrics, and we would like to specifically alter the update policy. Configuration is a JSON. So you can also see, because it's an array here, that we can have multiple update policies. But for now, we're just going to create a single one on this derived table. The source is raw metrics. So whenever new data in raw metrics is ingested, this one will be updated as well. So the transformed metrics. The function that will be executed is called transformed metrics. It's transactional one, which means that if this function fails, the transformed metrics, the original ingestion into the source table will also fail. Propagate ingestion properties is set to false. In case you are in some sort of a backfill scenario where you would like to ingest old data, sometimes it might make sense to propagate the ingestion properties here. So by executing this one, we now have an update policy set for this table. Again, to find out which update policy you set, you can use a show command. Show table transformed metrics policy update, and you see that there's a policy on this table. Now, those are the three most important steps of this part of our session. Again, creating a stored function, generating the data model of the new derived table, and making sure that all data which is ingested into the raw metrics also gets ingested into the transformed metrics. Okay, before we continue, let me just pause here. Any question?
Not right now. There was one about the MV expand, but I think we can go deeper into that at another point, but no more questions right here.
Cool, good. Now let's see what the tutorial has for us. So we did now this step and executed those three commands. We clicked on this link to get to the script, and then just copy and pasted everything in there in a new tab over here. Okay, now the next step is actually getting rid of all of the data that we ingested beforehand and ingesting a bigger data set, this time from a blob container. But let's do it step by step. So first of all, copy this statement here, which is clearing data from the table raw metrics. I'm going to do this in a new tab. So it says clear table raw metrics data. If I executed this, I now can validate that in raw metrics count, there's no data. In raw metrics, transformed metrics count is 0 as well. So we have no data in here. Now let's go to the second step of this part. We want to ingest the entire data set from this blob container into raw metrics using one-click ingestion. Okay, one-click ingestion. I think I heard about that. There are multiple ways to get now to this. You can either go to the home. You can go to data and just click on ingest data. You can go to query and you can right-click on metrics to ingest data. So there are plenty of ways of getting now to this experience. I prefer now for this session to click on ingest data. Again, I select the cluster that I'm interested in, the database, and now the first difference to the previous session, to the previous steps, is we would like to use an existing table, which is raw metrics. Now we decide on the source, and again, as said in this hands-on lab, we would like to use a blob container this time, and again, right-click here, copy the link. We're going to need it in a second. So the source type here now needs to be blob container. Okay. It's going to be a one-time ingestion. We have a specific URL. We can also select the container, but in this case, we have a specific URL. We are pasting it into the link to the source. And then again, a spinning wheel, which is doing a list on this blob container, and it found 3 JSON blobs. I could do like more things here to filter for certain paths or certain extensions, but it's not necessary in my scenario. So I'm selecting one of those files, and this file will be the schema necessary for schema definition, but actually in our scenario, it's quite irrelevant. So we see data that looks familiar to us. We also see now that there are fields which have multiple properties. Again, please select multi-JSON here. Nested level 1 is totally fine. And there's also no need to create a new mapping. Okay, so click here to use an existing mapping and select the raw metrics _ mapping. And you're done. Actually, nothing changed here. It will use the existing table. And if you're clicking now on start ingestion, it will ingest the data from those 3 blobs. This will take now some time, probably a couple of seconds or maybe a minute, and then the data will be ingested. Okay. Now we ingested data from those 3 blobs. All 3 succeeded, 0 failed. So again, can go back to my experience. I could also click on take 10, but this time I would like to click directly. Oh no, let's just do take 10. And here I am back into my database. And immediately this tells me that there is some data. Let's do again some check. So count is now giving me a little bit more data, just 500,000. So 538,000 were ingested. And now I can also check the transformed metrics. If this is bigger than 0, and there are 1.6 million records, most probably related to the MV-expand because it created multiple rows for one row in raw metrics. Okay, cool. That looks good. Let me go back to this advanced KQL script that I downloaded. It's still somewhere here. probably here. That's you can also give it a name. Advanced queries, so I won't forget about it. Let me get some more space here. And now what we did, just to recap, is we ingested into raw metrics. Due to the update policy, we populated a second table called transformed. And now transformed metrics has some nice columns and some nice secondary indexes which we can use. Okay, so that step is done. Let's take a look at the next one. Okay, let's just wait for this one and have a look at the actual queries. So we executed now everything until line number 28, including line number 28. Let's have a look at the count. We already did that. The transformed metrics now looks like this. So we have a specific row for a specific SQL metrics. The count is, of course, bigger, but the timestamps didn't change. So it's still the same timestamp here, 1 hour and 10 minutes and a couple of seconds. So just the number of rows changed. And now we can do some further querying. So we can, on this transformed metrics, we can identify the unique metric types. Again, SQL Server requests, I think we did that beforehand, but we had to do a little bit more for that, like parsing JSON. And now, like querying an individual metric type, like SQL Server _CPU, is incredibly more efficient because it will only query the secondary index. So the results will be much faster. And in line number 48, I defined that I would like the average of the value by SQL metrics, and I would like to have it binned by timestamp of 5 minutes. And this is the result that I get. So for this metric type, SQL Server CPU, I get several SQL metrics for several timestamps and their average values. Another way of writing that is, and this is also something that will be covered deeper in a session tomorrow, is using our make series command, which is translating the analytics from a row-based model to a vector-based model. So again, it's taking transformed metrics as an input. Now we're using only metric types of SQL Server _CPU, and we're only interested in specific SQL metrics. And this time, the first time that we're using the in operator. So it's something like that I could also specify, like SQL metrics equals SQL Server _process _CPU, or SQL metrics equals other process, yada yada yada. You get the point. So one of those things need to be present in that row. And let's have a look. And that we only get what we need. So the SQL metrics match, and the metric types is matching. Let's see, we get roughly 5,000 rows. And now if I'm using make series, it will give me something else. So I'm going to create a time series. I'm going to create a new column called trend, which is the average of value. In case in a specific time slot there is no value, I can define a default one. In case in this example 0, I want to use a timestamp column, and I'm only interested in timestamps from this date time to that date time. The resolution is 1 minute, and I would like to group all of these time series by the SQL instance. Executing this, I'm getting grouped by SQL Server by the SQL instance 2 arrays. So instead of returning like 5,000 rows, this is translated into a vector-based model. As you get 2 arrays here. One is called trend that I defined here, and one is called timestamp. You see, this is an array of values, and the size of the array corresponds like the array, the trend array has exactly the same size as the timestamp array. And this lets us do efficient querying on top of those arrays, which is much more efficient than doing it on rows. Again, I can render a time chart. So for this individual SQL instances, I get several drawings on the average value of one of these metrics. I can add or remove some of them, so it's not like a super great data set, but you get the point. The next one is giving us the last known value. So from the transformed metrics, we're interested again into SQL Server performance, and we're extracting the counter. We are only interested in certain counters, like user connection, data file size, kilobyte, and then we are doing an arg summarize with an argmax aggregate. We want to maximize the timestamp and get the last known row for that timestamp, and we're only interested in the value. And then we want to do this by counter. So the result set ideally should have the last known value of all of these counters defined here. So I'm executing this. I'm getting, for data size, file size in kilobyte, the last known value, log size, user connections, and so on and so forth. And this is really where like the KQL is shining with those kinds of statements or with the other statements that you've seen here. Now let's do some more stuff. This is practically a repetition of what we did before. So again, we're now this time we're interested in something else, like a metric type and a specific SQL metrics. And you want to render a time chart. It looks slightly different. Now the next thing is also very important. We're dealing a lot with time series, and what we see very, very often, especially in the automotive industry and also in industrial IoT, if you're working with sensor data, there's always the case that some data is missing. And if the data is missing, then and your time series is not complete, then some of the algorithms really struggling with like producing a decent result. So one big challenge for all of them is how do I fill up the gaps between missing values? Now again, the first part you already know. So I define that I want to have the average value. This time I'm choosing to have null here. So there will be no value, so not even a 0 on timestamp in a specific time frame by 1 minute. And then result would look like this. So I have an average value and the timestamp. You see here there are nulls in between, so there's no value here. Now my task is I would like to fill up those values. So from this value to that value, I would like to add remove the nulls and have something in here. Well, there are various strategies on doing that, and we have various functions to do that. There are fill functions to do a backward, a forward fill, a constant fill. I decided to use a linear fill. And then I'm only interested in timestamp and the new time series that I created. So let me just do that. You see the new time series, it has values for each and every row. Okay, you can render it here. And if I want to use something like a forward fill, it would look a little bit different. You see there's a straight line. So it took this one and copied the value to each and every step until the next one, until this one, at this point. But let's do a linear here. You see, it's not a straight line, it's not a constant line any longer. Okay, so now we are dealing a little bit with time series, and again, you will learn probably much more in tomorrow's session. Let's do some anomaly detection. The first part is already known to you, and that part is as well. And now I'm going to extend the data with another time series, and this time I'm interested in anomalies. So based on time series decomposition, ADX can find out based on the seasonality trend and the baseline what statistically means what could be from a statistical point of view an anomaly. And this is what we're doing with this function. And right after that, we are rendering this anomaly chart. And you see, based on this graph, this is considered to be an anomaly. So it also takes some seasonality into consideration. Again, like this is not like a super great data set, but it's actually working pretty well. And all of that is working without the need of training a particular model for a specific use case. It's just using statistics on the time series. The underlying array looks also like very simple. So for each and every data point in this time series, there's an element here in this array, and sometimes probably at the end there are a couple of ones which indicate that there's a positive anomaly. Okay, now we need some more data because it requires some data to show like how to do joins. So I would like to ingest now this new data set. But before we do that, are there some questions? If not, then let me continue. Okay.
Somebody was asking if there's can we easily ingest log analytics API query data into ADX given the JSON format of the API response? I'm not 100% sure of the.
It's like I don't get the question entirely, but what we know that you can do is you can export data from log analytics workspace to ADX. And then do in ADX whatever you like with it. We sometimes see that scenario where customer would like to retain data from log analytics for a long time, and or the other scenario would be that the customer has a large data set and they don't want to store each and every data set, each and every row in log analytics, and would like to choose a different storage, and then log analytics for some of the data sets, then they are using ADX. Yeah.
Henning also put in the chat that you can also do a cross cluster query, right? So from ADX, you can go and query directly data in log analytics. If the goal is not to import, but just to consult data, you can definitely you can do that. The link is in the chat for folks to see.
100%. So what just to repeat what Jill was saying is that given you have a log analytics workspace and you own an ADX cluster, so the scenario could be you have a complex application which is producing a lot of logs and telemetry, like I don't know, some Kubernetes cluster or some web app which is producing application logs, and you somehow want to correlate those application logs with some time series from IoT devices. And then you can do a cross-cluster, so-called cross-cluster query to a remote, so from ADX to log analytics, and also from log analytics back to ADX. This is a scenario which is used quite heavily. Okay, so let's take a look at the next step. This is, we finished this one. So we cleaned up data, we ingested data from the blob container, and we played with the remaining, some of the statements from this advanced scripts, from this advanced script. Now let's go to the next one. Some more advanced queries which require a different data set, so dimension data set, and we want to call it the server location. Again, same procedure. I'm going to go to, I want to do it a little bit differently. I want to ingest into this database. So I do a right click and I click on ingest data. I would like to create a new table, which is called server's location. I click on next for the source. It's going to be from a blob container. I think this time, please, make sure that it's a blob container. even if it's not like really necessary because it's just a single file. Again, go to this blob container, to this link, do a right click, copy link, paste it into the link to source. It's going to crawl. It's going to list all of the blobs on this container. Yoo-hoo! So it found one file. Yay! So let's use this. There's nothing really that we need to configure here. Please make sure that you ignore the first record, because the CSV file comes with a header. The mapping is totally fine. The commands here are similar to what you've seen before. So it's going to create a new table. It's going to create a mapping, this time a CSV mapping. And the schema will have a server, a column, a region code, a longitude, and a latitude. And let's click on Start Ingestion. Okay, data was ingested. I click on Take 10. It will open again the experience. And I have my server location. Yay. Now let's see what we can do with these advanced queries. So I just went back to this advanced queries tab. Now, because I gave it a name, I can find it easily. Okay, so let's go to the part, I think line number 90-ish. I think it made some modification in between. And now we would like to take a look at the server location. It's the first time that we are using a join. So for each and every server location, we would like to use this join. It's an inner join, and everything within this bracket is what we were going to have on the right-hand side of the join. So on the right-hand side of the join is transformed metrics. I'm only interested in a certain time range. And what I'm interested in is the percentiles of value by SQL instance. So what we get here then on the right-hand side is essentially for each and every SQL instance, we get a percentile of certain values for the metric type SQL Server CPU in a specific time range. And then we're going to do the join on the column from the left-hand side, which is server. And on the right-hand side, we match it with the SQL instance. And the project is just like limiting the number of columns that we're interested in, or projecting the interesting ones. So if I'm executing this, I see now for this region, West US, I have a SQL Server instance 2 and a SQL Server instance 1. They are in this and that location, and the 50th percentile of the CPU value is like 0. The 50th percentile is 8. In this case, it's 9. The 95th percentile is 92, and here 91. So this is some nice command to get an overview over entire regions. So if you have like multiple SQL servers in multiple regions, you would like to monitor the overall performance of a region, then this is a very, very helpful command. Okay, so let's continue with those. With I think the remaining one, and in this step, there's actually the only thing which is different here is we would like to have the max value by metric type and SQL instance. And you only want to have the top 5 by this max value. So it's another operator that you just learned. It's a top 5 operator by max value. You want to render it as a column chart. So there's nothing really specific here, just a different chart and some results. Okay, so we now ingested the server location. We used the advanced KQL queries, and yeah, we had a look at all of this data. Now, before I want to go to Materialized view, let's not take questions now because we want to finish somewhere on time. Okay, Materialized views. What are materialized views? It's an incredibly helpful feature in ADX to do multiple things. And what I'm going to demonstrate in this session is three different features, three different like things that you can do with materialized views. A materialized view for deduplication of data. So in case that you get an event stream of duplicated data, and duplicated data is something that's it's very, very painful, but it's something that we see in almost every project. Like customers send data either in a duplicated fashion, or sometimes they have to re-ingest data, and then you get duplicates in your data. And then later on downstream, when you want to do analytics on top of that data, sometimes you need to filter out those duplicates. Okay, but that's problematic. We have a functionality to do things like a distinct on a certain row, and then you can define either by a certain event ID or by a combination of multiple columns that this is supposed to be unique, but it all happens during query time. And usually those distinct commands, what they're doing is they're reducing the number of parallelism across the cluster. So you have a distributed relational database here, and if you're doing distinct, then everything is focused only on a single node. So all of the parallel processing power that you have on your cluster is actually reduced to a single node. So a better approach would be to create a materialized view, which is continuously running on newly ingested data. In this example, on the transformed metrics, and it's producing a deduplicated version of that. And the point why it's materialized is it's running this query on this data and persisting it in a table that you actually don't see. And then you can query all of that data, and the actual query will always return up-to-date data because it's joining data that has already been materialized with the data that has not yet been materialized. So something like a small, old school Lambda architecture directly in the database. So this is what this deduplication is doing. There's a specific option here which is set to backfill true. As you know, we already have existing data in transformed metrics, and backfill true means that we want to backfill also the already ingested data. Downsampling, this is sometimes needed if you want to analyze a certain KPI, and that KPI spans, multiple days, weeks, or months. So something like a year, month-over-month comparison of the performance of a certain asset. And depending on the frequency that you get data and an amount of data that you get, it might be actually billions of rows that you need to process for each and every summarization action, like doing the average value, the min, the max by certain metrics, whatever. So it's going to be a huge operation. And in general, it will perform good, but there's always room for optimization, and this is one of these optimizations. And it's called downsampling because, as you see here in the statement, it's doing the average by a certain time span, so an hourly average. So in case you have assets producing data each and every second, this materialized view will only persist one event per hour per SQL metrics, metric types, host, measurement type, SQL instance. So all queries on top of that KPI and on that materialized view will be super fast. Last but not least, the last known value. It's something, so given you have, again, an asset which is continuously getting new data, and you only want to see the last known value of a certain property, then again, you can query that with a simple argmax like we did in one of our examples. But if you persist the result of that argmax, the query will be much faster because it does not need to go through, all of the extents which are stored in this database. And that's what we're going to do now. So though all of those queries are at the bottom of your advanced queries script, we're going to start with the first one. It's called create async materialized view with a backfill true on this table, and it's going to execute this summarize statement. Now, if I'm executing this, I'm executing it async. Okay. Async means I'm not going to wait until the materialized view was produced. It just gives me an operation ID. And now I can use the function, the command in line number 120 to actually look up the state of that MV creation. And what you see here is it was an MV materialized view operation. It started at a specific time. It ended at a specific time. It just looked like it took like 15 seconds to deduplicate the entire data set, and the state is completed. Yay! But why don't I see it? Why don't I see the materialized view? Again, it was an async operation, and it was created for you, but the metadata in your browsers does not have it. Okay, so just do a refresh here, and you will see your new materialized view, which is called transformed metrics deduplicated. Now, if I'm doing a count here, I'm going to have, I see that I only have like 289,000 unique metrics, whereas the transformed metrics is, I think, 1.6 million. So I reduced the data set quite nicely. Now, the downsampling, remember, those are the statistics on this bigger data set. So for the downsampling, I would like to actually not run on the source data set. I would like to run on the already deduplicated data set. Now I'm creating a materialized view on top of a materialized view. Beware, this feature is still in, I think it's still in preview, but it's very, very helpful, and I don't want to miss the opportunity to show it to you. So we create again another materialized view async. We call it transformed metrics downsampling, and we run it on another materialized view, which is called transformed metrics dedup. And it's going to again do a summarize. And this gets the average value, the min, the max, and last but not least, it's going to bin that by an hourly time span. So if I'm executing this, again, I get an operation ID. I can use this operation ID to look up the status. It's already completed. I'm refreshing my metadata in the browser, and I see that I get the new downsampling materialized view. So let me use it here. Transformed metrics downsampling. Let's do a take 10. And I get now for this hourly timestamp of this metric type, host, SQL server, and a SQL instance, an average value, a max value, and the min value. Okay. Like write bytes, you see you get all of these statistics now aggregated on an hourly level. Last known value, this can be safely executed on a transformed metrics itself, so it's not really something that we need to deduplicate. Same game, it was an async operation, that's why I only get the operation ID. If it was already done, yes. So the materialized view is now a last known value. Let's try it out. So this, I was executing this on the entire data set to get the last known value of this 1.6 million rows, and it returned with 570 records. Nice. And now what you actually can do if you want to like show some sort of a dashboard, you can use this last known value to present the last known value of a certain asset. Okay. And even on top of that, probably it's also something that you're going to learn tomorrow. You can use a query results cache, and this is a very, very important feature if you want to have nice and snappy dashboards. The last materialized view that we have here is called transformed average value with the server hierarchy. Again, we're going to use the transformed metrics in here, but we're going to also have the server location. We use it as a dimension table. Okay, let's just create it and see what happens. Okay, it was complete. Let's refresh. It's called average value by some hierarchy. So what you learned here is that you can also use a dimension table for your materialized view to enrich the data in the materialized view. So yeah, you've seen now 4 different cases for materialized views. So that's an incredible feature for doing deduplication, downsampling, last known value, enriching data with dimension tables. And it's super fast to query it. Okay, before we go to the dashboards, I think it's the last step here. Let's just pause for a second. Are there any questions? Okay, wow, guys, you already published 41 questions. Nice. Cool. So then let's continue. Last but not least, so this time you actually also need to do something. This is not something that you could like fully automatize. So we're now going to build a dashboard. Okay. Building dashboards yourself is actually very, very simple. We could just like try to build one ourselves, and then we use the one that we already pre-created for you. Before we go into this dashboarding, experience, I want you to copy your cluster URI. It's here. This is needed in order to define a data set for your dashboard. Then you can go to dashboards. You click on new dashboard, give it a name like hello world. You click on create. This will now open the dashboard editing experience. The first thing that you want to add is somewhere a data source. So click here on those 3 dots, click on data sources, add a new data source, and then it asks you for the source name, so my free cluster. And now it just pastes the cluster UI. If you click on connect, it will use your identity to authenticate on the cluster and find the database. And you can also define some caching. I don't want to have any caching here, and you just click on apply. Now from this point on, you can use this data set or this cluster connection in your tiles for your dashboard. So I could now write something like summarize count by SQL instance. I can execute it, and then I create a visual for it. All my SQL instances, and because I'm a fan of pie chart, I'm selecting a pie chart, and then I'm applying changes, and here we are. Okay. So you have your pie charts of all of your SQL servers, and you can start working with it. And what we're going to create now is we're going to create a new dashboard, and we're going to import it from an already existing one. Okay. So the way to do that is, again, import and export a dashboard. So the best way of doing this is clicking here on this link, and then you get a big JSON. Okay. The way that I am handling this, I'm go to Visual Studio Code. I'm going to paste it, and then I'm going to run a command to format the document, and then you see the entire JSON in here. And what you want to configure is, you don't need to configure the ID or the e-tag or the title, that's all fine. But what you definitely want to configure is your data source. So the data source is somewhere.
If you don't have Visual Studio installed, you can also do that after you have imported it.
Yeah. So here. So we have the two data sources defined here. And I'm going to use, let's leave the help cluster in here. That's still fine. And I want to use my cluster URI here. So my cluster UI is, let's go back to my free cluster, is this one, the cluster URI. I go to this one, let's paste it here. My database is my database. And that's it. Going to save that somewhere. And then I go to the dashboarding. I click on import dashboard from file. I'm opening it up where I stored it. Give it a. Now we have a nice dashboard with some of the things that we already did before. And we have a list of nice widgets. And don't forget to save it, by the way, because this is now just in this browser instance, and you definitely want to save it. And now you can go to the viewing part. If you go back to dashboards, you will find your hands-on lab dashboard in here. It has all of the data, and it's going to use data most of the time from your cluster, but there's also the help cluster in it, but I don't think that it's actually used. So we see here the latest values of user connections, number of deadlocks per second, data file size in kilobyte, the log file size. You get temp table statistics, and like number of active temp tables, the transactions per second, the collected metrics for server, like SQL Server metrics. You get the CPU usage, a global distribution in a nice map, geographical map visualization using Azure Maps. The actual search metrics, average values you get here as well. And then some of the queries that we did on memory utilization and anomalies in SQL Server perf metrics. You see here anomalies in the anomaly detection. So we started with the very, very simple logs from SQL Server, and within 2 hours, we were able to create a nice dashboard. And now new data that comes in will be automatically translated, transformed into the transformed metrics. All of the materialized views will be up to date, and you can query your data. Yeah.
Henning, we have a question about parameters. Can we discuss this real quick?
Yeah, absolutely. So let's say we want to add parameters. Okay, let's go back into the editing mode, and I would take a look at parameters. There are already some predefined one, like the start time and end time. I don't think that we used the start time and end time here because it was like the data was like way in the past. There's one more parameter for data hierarchy, but we can also create our own parameter. Just click on new parameter. We call it, I don't know, SQL Server. It can be a single or a multi-line selection. Let's do a multiple selection. I call it underscore P SQL Server, data type string. And now I could either go for a fixed query, a fixed values, or for a query. I'm of course going to do a query. So I'm going to look into what was the sample metrics I want to use. What was the function? What was the thing that we created? Give me a second. Turkey. I would like to have a SQL instance. Okay, probably my data set is not entirely fixed. Let me see what I can do here. Okay, and let's go this other one. Now I want to create a parameter. Multi-selection, the SQL. Data type is string, yes, query. I would like to do it on, I should have used the other one. Okay, my fault. And now I would like to have the transformed metrics, and a distinct SQL instance. Let's do an order by SQL instance ascending. Also not super nice, but better. And in the value column is SQL instance, the label column is SQL instance. The default value would be select all. Now I have a new parameter, and let's adapt some of the queries that we have. In order to do that, I'm going to do a small trick, because whenever you create a new tile, okay, it automatically generates those comments here, which help you to use your parameter quite quick. So I'm just using this to copy the stuff, and then I want to go to, let's use this one. See, it's using the average value with the SQL Server hierarchy. So we have the SQL instance in here, so multiple of them. And now I would like to filter on this pSQL instance. And now I just need to define the column name, which is SQL instance. And if I run it, nothing changed because I selected all, but now if I'm only interested in SQL Server 2, see, I'm only getting SQL Server 2, and I'm interested in SQL Server 1 and 6, then I only get values for those. Now if I'm saving this, then I can select I'm only interested in SQL Server 1, but I just now edited this single widget. So probably I would now need to do the same thing for all of the other ones. Okay, parameters. Good.
I can add that we're also working on what we call a base query, so we can have a base query which all the visuals are based on, and then that will reflect easier in a dashboard like this. There's a question about materialized views. If you can elaborate a little about the effect on the cluster performance, workload, and so on. Should we just use materialized views all over the place, or should we limit ourselves?
Yeah, that's an excellent one. So let's go into our query experience and let's just look at a concrete example. Okay, so we look, for example, at one materialized view to get the last known value. Okay. So let's just see what this one is doing. And last known value is doing the argmax on all of that stuff. And it's returning to me. Let's have a look at the statistics. Statistics is actually saying that it took some time to execute it here, like 12 milliseconds. It's not that much data. And then there's also a raw JSON, which tells us that the execution time was again like 12 milliseconds. There was some time that it spent on as a total CPU, so across the entire cluster, and one extent was scanned here, which was ingested here. So it actually, like, all extents would need to be scanned, but at the moment it's like not that much data in here, so it's hard to show that. But if I'm now querying the materialized part of the materialized view, the same one doing exactly the same thing, the statistics will actually show that the execution time is like 10 times faster, and most of the time is on the translate and sending all of the data from the server to the client. So what that usually means is that in case of a bigger scenario where you have like a lot more data, materialized views help you to scan less data and to process less data on the database. Because it's doing all of the downsampling and the deduplication and all of the adding dimensions, it's doing that pretty close to the ingestion time by iterating over the newly ingested data and always trying to process the newly ingested data and execute that summarized statement that you've seen in the materialized view, and then persisting the result of that. So it's very, very efficient. But now the point that Core made is very, very important at the same time. Sometimes if you have a lot of data, like millions of requests entering the systems per second, tens of terabytes per day being ingested, or even more, there are like a lot of CPU cycles which are spinning on creating that materialized views. So one materialized view might still be okay, but depending on the size of your cluster will need to spend quite some amount of its CPU on materializing the data and running that query. So if you're using materialized view, depending on the size of the data, it might be required that you scale out your cluster. And usually that's not a problem. So you can horizontally and also vertically scale out your cluster until it actually fits. Until it fits your use case. But if you're looking at materialized views, they are very, very powerful, but you also have a lot of like responsibility to select the right spot for them, and not to potentially create load that and you don't have any benefit from that. Yeah.
Thank you. I guess that was the question.
Good. Any other questions that came up?
Yeah, there's one about cross-filtering from in the dashboard.
Yeah, it's supported. So I think we can try. I can try my best. Let's see. Where is it? Here's my friend. Let's see if we have a SQL Server somewhere here. SQL Server requests, database. So collected metrics. Let's see what this one is doing. Oops. Let's go back. Let's go into edit mode. And then if we're editing this widget, you have an interaction, okay? And that interaction leads you to a cross filter. And I could say I'm interested here in the metric type, and then I can map it to a certain parameter. Right now, I did not create that parameter, okay? But you know the exercise. So first create the parameter for this metric type, and then you can use this metric type. So whenever you click on it, this parameter up here will be set to the metric type that you clicked on, and then all of the other widgets will be filtered on top of that. Okay. Other questions?
Nope. No new questions.
Okay. Give me a second. Okay. So let's have a look. Yeah. So now, if you would like to continue with that, you would like to continue with your experience, we have some example of live data sets. We created a data generator. It can be found in this repository, and then you probably want to educate yourself a little bit about ingestion using Event Hub, because this is what this is all about. And then you can ingest data through an Event Hub into Azure Data Explorer. One thing that you need to keep in mind is that for this experience, at the moment, you still require an ADX cluster, so a paid one, because the free cluster does not yet support Event Hub ingestion. So for this, if you want to go through that kind of exercise, you feel free to follow those steps. It will be not that much different from what you've seen here, just with the paid cluster. Okay, Core, would you still be able to do the session?
Yeah.
Or should we do that?
I can.
Okay.
Let me just take the camera and the screen. So, hi everybody, my name is Kåre Rasmussen. I'm a cloud solution architect and actually Microsoft Denmark. For the past half year, I've been working as PM for the Custo team, or the Azure Data Explorer team, working alongside the great people. And one thing that I'm going to show you today, that is about a system called Home Assistant, and talking about a live data generator. I think this is close to a perfect one because it's actually really live data. But let me just share my screen here. So first of all, I just have I just posted this link. This is a feature comparison between a paid cluster and the free cluster. And as you can see, we have materialized views as a feature on the free cluster, but autoscale and scaling in general is not part of the free cluster. So with the free one, what you see is what you get. So those two things can work towards away from one another. But we have quite a few of the features is actually already here. And the demo I'm going to show you today is also based on the free tier. Another thing, we have a link here for, I'll also post that later. You can actually go and create ideas and then vote for your ideas. So if there are some features missing, of course you can talk to us, but also go in here. We are looking here to find out, what is the most sort of features that we want to expand on Data Explorer. Okay, and team, please stop me here if there's a question or anything. I can't see the chat while I'm presenting here. So the demo I'm going to show you today, that is about Home Assistant. Some of you might know Home Assistant. It's I think it is probably today the biggest non-commercial open source system to control your smart home. More than I think 50,000 developers and hundreds, maybe 200,000 users across the world. What you get with a Home Assistant is something like this. This is my personal Home Assistant, where you can connect all kind of devices throughout your house, your apartment, wherever you live, and then you can basically start manipulating, creating maps, creating automations, all the stuff that you think. But you will also be able to create a lot of data. So here, I'm sorry for this being in Danish, but as you can see, the electricity price is red because it's just way too expensive. But here I have all kind of data for my energy meters. I have temperature data. I have, I'm just going way too far down this road. But we have this system running on a local on-prem machine, gathering all this data, and I want to be able to actually analyze this data. The local setup is, of course, limited by, many is running this on a Raspberry Pi, a similar kind of compute device. So very little muscle, especially when we want to work with a bigger data set. Okay. Here I have a vanilla installation of Home Assistant. There's absolutely nothing here except, as say whether it's sunny or not, and it's actually sunny today for a change. And I want to take the data coming from this Home Assistant and send that to Azure Data Explorer. So in Azure Data Explorer, I have created a free cluster, just as you learned today. And then in that free cluster, I have to do a few things, because we need an application to send data to another application. So for that, we're going to use Service Principal. So in this script here, I will set up a Service Principal, which I have already created in Azure, to have ingester rights and viewer rights. Then I will drop a table and then actually recreate the table. So create a table to store the data that I'm having. And then I want to create this ingestion mapping as I guess you learned that yesterday. An ingestion mapping, because the data generated from the Home Assistant is in Json. So I need to map that into that table schema. And then lastly, I have a policy about ingestion batching, where I will set up the batching of this data. If this was a paid cluster, I actually could use streaming data and stream the data directly into the database. This is a free cluster, so streaming is not a variable yet. So I have to set up the batching policies. And this little command here will actually says that I want to execute all of them. So I run them. Hopefully it goes good. We have completed all the statements. And now you can see I have this table called HA raw with these entities. So how hard is it to then set up my vanilla Home Assistant to actually send this data? In Home Assistant, there's a notion called integrations. In integration, we can add a new integration. And then we can search for Azure, and you can say we have Data Explorer, we have Event Hub. Event Hub is already there. Data Explorer is coming very soon. It's not completely out there yet, because it's waiting in the backlog to actually be approved by the Home Assistant team. It's for those of you who know Home Assistant, there's a system called Hacks, and it's already available in Hacks. So you can do this if you have Hacks. But what you will end up in an experience where you click here, and here you basically just need to add in some few information. What is the UI of the table? What is the database name? Then I put in the table name for the table that I just created. And then lastly, we need a few informations about the service principal that was created early on. It's part of the documentation how to create a service principal. And then this checkbox here is whether we want to use the queuing, which is the only thing supported for the free cluster at the moment, or we want to use the streaming. So I'll use queuing, and then I submit this. And with a success, we are set up. So everything that now will happen within Home Assistant, all the data that I have, lights going on, lights going off, temperature sensors changing value or what have you, all of that data will now actually be exported to Azure Data Explorer. Right now, if we go here and we look at AJ Raw, we will have nothing, and that is because we are using this batching input. So stuff here will be batched up for a certain amount of time. But let's try to just make a change. And then we have to give it a little time for that change to propagate through the batching of ADX. Meanwhile, I can actually show you, just switch to another account here. And make sure that I have the right one. Here we are. And here is called A raw. So here you can see I have 24 million rows already, and we can start looking at this data. This is my real Home Assistant installation giving data here. So we can look at, for example, a map. This map will show you where my car has been for the last 7 days. We can expand that to 30 days if we want. The car is also connected into the Home Assistant. So here you have, and you can see I live in Denmark, where I've been driving around in Denmark for the past time. We can also look into the management, seeing the stats, how much data is actually being sent from this instance. You can see about the server itself. I have some metrics from that. There's apparently a memory leak somewhere that is being, once I restart, it's going away and then it's coming. I have to look into that. But all this data, you can see, we come from a limited view here, where we could look at a simple metric. We could look at over a quite narrow set of time, to actually having a fully supported, fully queryable access to all the data. Let's see if the data has arrived yet. I'll just go back to and it is this one here. Wasn't it that one? Oh, still 0. They will come. So we have basically the possibility to now just look into all this data. We also created another quite interesting integration. For those of you who knows Node-RED, we have now created in Node-RED, it's up here, a Node-RED block So you can, or Node is called. So you can connect the Node-RED. In this case, it's connected to an MQTT server. All the data going into this block is sent to Azure. So if we go back here and look at the right one. Actually, I think this is the wrong one. So this is not, it is because it's here we are. So here we can see data is being produced from that Node-RED instance and sent to Azure. And again, from here we can do all kind of functions. So we have update functions here. If we look at the data, for example, the data in the table it's looking like this because that's the way it's generated from Home Assistant. And in this, we have data inside of JSON, outside of JSON. So I created an update function to basically take the data that we want and put that in a more readable schema like this, which is easier to actually read in tables, etc. Any questions on this?
No, not so far. It's looking great. I still owe you using the Node-RED.
Yeah. So I can definitely, if you're into to Home Assistant or home automation, the Home Assistant project is actually quite powerful one, and it's getting a lot of traction. And now ADX or Kusto is also connected to it. So have fun.
Cool. Wow. Thank you so much for this demo core. What you've seen is that even with this quote unquote with the free cluster, you can do amazing things with your home automation. I'm doing similar stuff at home, and by the integration with Home Assistant and Node-RED, it's getting very, very easy for you. So yeah. So what you've learned in today's session, let's just do a quick recap. Let me share my screen. We went through a couple of steps. So we created a free cluster. You created your own cluster. You can use it even after this session. And you learned how to ingest data, how to transform data in the database itself using update policies. You also learned how to query raw data sets in JSON. You run pretty advanced queries, and you did joins, summarization, time series queries. Last but not least, we even created materialized views, multiple materialized views for downsampling, deduplication, enrichment using dimension tables. So many things were covered in today's session. And last but not least, we showed you how to create dashboards. We believe that this is a good set of basic capabilities to start a successful ADX, Kusto, Synapse Data Explorer, Kusto for free project. Thank you very much for attending this session. It was a pleasure. Also, thank you to Jill, Diana, VP, and Core for staying with me, for answering all of these questions. It was a pleasure. I wish you a nice rest of the day, and tomorrow there's going to be the last day, and we're going to cover very interesting topics on time series and ML capabilities, mind-blowing stuff. We're also going to talk about how to optimize for highly concurrent queries. And last but not least, we have a dedicated session on how to create powerful Power BI dashboards and ADX dashboards. Thank you so much. Have a great rest of the day. See ya. Bye-bye.